Hello, and welcome back to the Cave Escape podcast. I'm Caleb Groves,
And I'm Ashton Goolsby.
and today we are going to talk about astronomy, because astronomy is important, and it kind of gets thrown into the category of non-important sciences, I feel like, a lot of the times. Like, it's kind of...
It's usually not one that's taught in high school. It's
Yeah.
You can talk about it in elementary school, and then, oh, that's kind of cute, and then we move on.
Right. Like, chemistry is normally required, and, like, physics...
Biology.
And biology, all those are like, you have to take these sciences. But then astronomy is just kind of like, you know, you can do that if you want, but it's not really important. But that it is actually really important because it has a lot to do with our daily lives and also like navigation, which is also a part of our daily lives, I guess. And specifically, primarily we'll be talking about the history of astronomy, and how the development of the study of the heavens and kind of how we got to where we are plays a role in how important astronomy is to our daily lives.
Yeah, I think that was kind of what we were talking about earlier.
Yeah.
Yeah, so, I mean, astronomy, well, it was very important in the ancient world, especially to the Greeks.
Mm-hmm.
So astronomy, not to get super nerdy, astronomy, astronomos, means star name, so that you're naming the stars.
Right.
So astronomy is just naming the stars. And something that was noted, I'm thinking primarily of when we talked about it, we're talking about Greek people, but I mean, across the world, they noted there's the stars, and the stars all kind of move together. And they started picking out individual ones, and they would name them when they form constellations. And then they noticed not all of the stars move across the sky in together. And so there were 7 they picked out that didn't move with the other stars. So it was the whole sky kind of rotates together. But there were these certain stars they noticed didn't always appear in the same place, and they didn't always move with the other stars at the same rate. And these they called wandering stars, which we now call planets.
Right.
So planet just means a wandering star. And so the ones they picked out were the 7 planets where you had the Sun, Mercury, Venus, the Moon, Mars, Jupiter, and Saturn. And so those are all the planets you can see with the naked eye. So they could go outside at night and they could see all of these, and they had to figure out how on Earth can we have all the stars move together and then have 7 that just kind of wander around. What's causing them to do that? Why are they doing that? And so that was the foundation of the study of astronomy, is they looked at the world and said, hey, there's this phenomenon going on, we need to explain it.
Yeah.
Which is ultimately what, I mean, most of science is.
Right.
All of science is just you're looking at the world and saying, this is something I observe. Why does it work the way that it does?
Yeah. And so they initially, like, one of the initial explanations, I guess, was like spheres, right? So like 7 spheres. You had Earth, and then you had the sphere of the moon was first, right?
No, it was the moon. Sorry, you're right.
So the moon, and then the sun.
No, it was the moon, then it was Mercury, then Venus, and then the sun. That's actually really cool. They figured out that the moon was the closest one to us, and then it was Mercury, then Venus, and they were between us and the sun.
That's crazy.
They figured that out because they could tell the moon can move in front of the planets, so it must be closer to us.
Right.
But also, Mercury and Venus appear close to the horizon. They're close to the sun. And so they had determined with that, and there was some other slightly more complicated thing I think they observed that I can't remember. But they had observed through relationship of time and placement that the moon has to be the closest one to us. And then somehow Mercury and Venus are between us and the sun.
That's totally crazy.
If you look at, they have the order of the planets pretty much right.
Yeah.
If you're looking at it from Earth, and they perceived Earth, of course, was the center, and so everything else is going around it. So if you look at their model, it makes sense.
That's really cool.
Yeah, it's crazy how much they were able to figure out just looking from the Earth.
Yeah.
Now, of course, they were ultimately incorrect. The Earth is not the center of the
Right.
solar system.
Yeah.
But it's crazy they were able to figure out as much as they did.
Mm-hmm.
Which
Yeah.
is... Sorry, go ahead.
I was just gonna say, one of the things that I know we've talked about is like the fact that, like you just said, they were ultimately incorrect, and a lot of people are like, see, they were kind of dumb, and they didn't realize that the Earth was not the center of the universe. Is kind of how I feel like a lot of people talk about it. But like it was actually very intelligent because they had no reason to believe that like the Earth didn't move around or wasn't the center of the universe, and like that's what it looks like. And that even comes back to one. So this was one of the most fascinating things I think that I learned in cosmology at New College, was that basically all of astronomy is just trying to solve the problem of relativity, because everything is relative, and so relative to our point of view, our like frame of reference, we stand still, and everything else moves around us, which is very related to like Einstein's theory of relativity, where you have your frame of reference and things move relative to you. And so like if you throw a ball at me at 10 miles an hour and I'm running at 10 miles an hour from my frame, or I'm like riding a bike, say 15 miles an hour, that ball is coming at me at 25 miles an hour. And so from my reference frame,
it's coming at you.
The ball is moving at me at 25 miles an hour. But from your reference frame, the ball is moving away from you at 15 or 10 or whatever I said.
Yeah.
And so your frame of reference can change like how you perceive reality, but it doesn't invalidate your perception. And then your frame of reference can also change how you perceive gravity. It can change how you perceive time and light, and like how long things are. Like when you're moving 80% the speed of light, things look like they're shorter. Yeah. But it's not that just like you're moving really fast, so it kind of has this weird like effect making them look like no, they're actually like if you were to measure it, they would actually just be shorter. Which is like a super weird thing.
Yeah.
And so like relativity, but then like back then, right? They thought the Earth was the center because they're going from their frame of reference. And so it makes perfect sense that that's what it was. And then the whole time they're just trying to figure out how do all these other things move relative to us, and what kind of model can we come up with that will predict this accurately.
Yeah, and so science, one thing I remember we talked about a lot was the changing models of science. So science works largely off of models, but to an extent they don't believe the model to be how it actually works. Like the model of an atom that we still use, we've disproven that that's actually how an atom looks. But we still use it because it's helpful in understanding it. So a model is just a tool that's helping you understand how the thing works in reality. So like you were saying, like we look at them when we go, well, they were dumb. They thought the Earth was in the center. Clearly it's not, so what did they know? But, I mean, if you think about it, if you're just born into the world and you don't know anything about anything, it takes a lot to figure out, hey, there's 7 things in the sky, there's 7 of those little pricks of light that don't move with the other ones, and then to piece together very closely the order that they actually lie out in without actually going into space. We have the advantage now we can send space probes out, or we can actually go there ourselves. They didn't have any of that. Yet they were able to figure out quite a bit of how it actually works, and that's very impressive.
Yeah, and if they didn't do all the things they did and figure out the things they figured out and come up with the models that they came up with, even though they were incorrect, we wouldn't have been able to get to our current correct understanding. Like Copernicus deciding, hey, you know what, maybe the sun's actually in the center and it's not the Earth.
Yeah,
he couldn't have done that without all the like hundreds of years of the Greeks studying this and coming up with all these theories and models and things. Also, did you finish saying the thing about you may have just touched on it, but like all their models that they came up with, they weren't actual, they didn't see them as like explanations of what's actually happening in the sky. They were more like, I forget what the phrase is, like mathematical models, where like you punch in the numbers and you get the correct number, but it's not technically like an actual explanation or description of what's actually happening.
Yeah, they eventually got to, because
They're more like predictive.
yeah. So initially, the most simplest, they always said the simplest answer is the preferred answer, is the scientific rule. The simplest answer you can give, or the reason you can give for something, is the one that should be accepted.
Mm-hmm.
Because there's this kind of understanding that the universe is not overly complex and confusing. It's intelligible. It wants to work on the simplest premise possible. So the original idea the Greeks had was the Earth is a sphere in the center. Yes, they believe the Earth was round, because if you go out and you look, which we'll get into in a minute, you can tell where you are on the Earth based off of the sky. Obviously curves, and you can walk over the curve, and we'll talk more about that in a minute.
Mm-hmm.
So they knew that the Earth was a ball. It was round in the center, and they concluded that the maybe on the far outer edge there's this big sphere that has the stars all stuck in it. And so that's why the stars all kind of move together, because they're all stuck on this big backdrop that encompasses us like a cage. Now, in between them, they had these 7 glass spheres that you could see through them, but on each sphere they had one of the planets was stuck into these spheres. So they viewed it, I guess, kind of like a Russian nesting doll.
Yeah.
Where you've got this one in the center, and you got these other ones, these glass spheres with the planets that close around the Earth, and eventually the backdrop is just the last shell on the outside.
Mm-hmm.
And so that was the simplest model. It kind of made sense. And then they eventually realized, mathematically, it doesn't explain some things like we were talking earlier about retrograde motion.
Yep.
So retrograde motion is where a planet will kind of continue going one way. So if you're tracking it over the course of nights, it looks like the planet moves one way, then stops and slowly comes back, loops on itself, and then goes back forward again.
Mm-hmm.
So it doesn't move in a consistent pattern. And they were trying to figure out ways to explain that. So on top of that, they said, well, maybe as they're going around Earth in these spheres, they're also inside these other tiny little spheres that they kind of, as they're rotating around us, they're also spinning in another circle on another axis.
Right.
And they started getting more and more complicated until finally Copernicus, he was the first one, but he was the one who popularized. Yeah. Maybe the Earth is in the center. But it was trying to explain away how things like retrograde worked.
Yeah.
So the model that they had was good for getting them the positions of planets.
Mm-hmm.
It was decently accurate at getting
pretty close.
Yeah. But it was really complicated.
Right.
But it worked for what they needed it for. But then Copernicus really pushed the idea that nobody really wanted to look at, which was maybe the sun's in the center and we're thinking about it backwards.
Yeah. Which, interesting, he did pose it as this is actually what's happening out there. And because before, they did assume that, like, the Earth is actually a center, but they didn't necessarily actually think that there were like, actual glass spheres, I don't think. And I know, like, the epicycles thing wasn't necessarily, like, they're saying this is exactly what's happening, where you've got this tiny circle that's spinning while it's going around on a bigger circle. Those were just, like, models to get them the mathematical answer they needed. Yeah. And so Copernicus actually was like, no, this isn't just a model. This is actual explanation. I think this is actually what it is. And whoever his buddy who, like, I think published it for him, he wrote like a intro to it, which he published. I think it got published like a few days before Copernicus died. I can't remember how many. It was like 2 to 4 days after it was published, he died. So he didn't actually get to see like it come all the way to fruition. But this guy wrote like a preface to it, kind of what's the word? He made it sound a little bit more like Copernicus was like, no, so this isn't actually what's happening. It's more of a model. And so he kind of like talked about it in that way to kind of ease it a little bit because he knew that like the Catholic Church and everybody was going to totally flip out if somebody was like, the Earth is not the center of the universe, like they did when Galileo said that, and they were like, we're gonna kick you out of the church. What's that? There's a word for that. Excommunicate. They were gonna excommunicate Galileo if he didn't revoke or recant.
If you don't revoke what you said.
Yeah. And so
that was another thing too that shocked me when we were talking about it in college was the level of influence the church had over this stuff too. The church, we tend to think now of the church as its own thing, and everything else is kind of separate, and so, which I would say goes back to a flaw in the education system. We think, all right, math is here, science is here, history's here, church is over here. All right, they have their little boxes that they pertain to, and they keep in. I mean, everything was interrelated. Yeah, it was also all understood. That everything was understood to exist in light of the gospel, and thus needed the church's what's not approval, but input on it. You needed the church to give input because, I mean, everything's part of God's creation. Mm-hmm. Well, the church is the one who teaches us about God, so have their input on it. They were very much involved in it. And the problem with this new proposition from Copernicus was, if man is made in the image of God, then man is the focal point of creation, because we're the image bearers of God in the creation. Therefore, it makes sense we would be the center. Earth, our home, would be found in the center of the universe, or, well, they would have said the universe. Yeah. So everything else goes around us because everything is there to serve us. So we're the center. Right. If you're posing that something else is the center, that was pretty much heretical. Yeah. Because it does away with the idea of man being the center of the universe. Right. And so that was a really big deal for them. That's why they were willing to excommunicate him over it. Mm-hmm. Because you're basically making an attack against man's centrality in the created order. Right. And one thing that Miss Wilbur always says, or Greg, I guess I can call him Greg now. I still don't really call him Greg. Is the... Oh my gosh, I totally just forgot. He always says this. Oh, yeah. Like there is a way in which the geocentric system is true, because, like, does the sun serve the earth, or does the earth serve the sun? Yeah. In God's economy, in God's creation, the sun gives earth the heat and the warmth that it needs to sustain life. And so the sun is serving the earth isn't actually serving the sun. And so there's like a philosophical, I guess, more truth to the idea of a geocentric system. Yeah. Even if it's not actual reality, like there's still some more of like the philosophical reasoning behind the earth being the center of the universe is actually kind of correct. Yeah, and that's part of why, even as I'll teach my fourth graders astronomy, I was just lesson planning or doing my year plan for this new year. I'll teach them the Ptolemaic one, the ancient model. Mm-hmm. I'll teach them that one, and then we'll move to Copernicus, usually in the same day, if not the next day. But to give them this idea, because there is benefit in understanding the Earth, while not physically located in the center, is the reason the other ones move the way they do, is to serve us. Like you're saying, the sun heats us, but then you've got these asteroid belts, you've got these outer lying bigger planets that block us from asteroids. The moon. The moon's big about blocking us, but it also, tides and things are affected by it. Yep. So I mean, there's a sense in which, Earth is the only one that can have life on it. Yeah. So the other ones are moving in a way that kind of has the Earth as the center. Yeah. And the other planets' orbits also affect our orbit, right? Mm-hmm. I think that's true. Yeah. So we're placed where we are, and the other ones are placed where they are for the benefit of us that live on this planet. Yeah. Through the design of God. So there's benefit in understanding the ancient model and the modern one, because while ours may be more physically, technically correct, which is a good thing we need, there's benefit to the older way of looking at the world, the way they philosophically understood the way stuff fit together. Yeah. But another thing that we were talking about earlier, which is something like it interests me, which we can get to in a minute, but astronomy was also helpful and is still actually helpful today in navigation. Mm-hmm. So for the longest time, if you were sailing on a ship, you reference the stars. Now, referencing the stars can only get you your latitude, which, if you don't know longitude and latitude are the lines on your globe that run east to west, and you actually measure north to south with them. They're like ladder rungs running across your globe.
Mhm.
So you count how many of these bands across you're up or down. So if you're standing on the North Pole, if you're standing on that latitude, the North Star should be directly over your head. As I walk down toward the equator, it slowly starts sliding down toward the horizon line. And that was one way that the ancients discovered that the Earth must be round, because they discovered there's if you watch the stars and how they move from if they would travel city to city, they move as you would expect them to if you're walking on the surface of a sphere.
Right.
They slowly curve and rise up and down as you move.
Mm-hmm.
So measuring angles of stars and things, they figured out the Earth must be round. That there were other ways too, but that was a big one. So when they were sailing, they would look at the stars and they could determine how far north or south they were. The problem came in, it's easy, piece of cake. I can teach my fourth grader how to tell how far north or south they are.
Right.
All you need is your eye and a protractor. The difficult part is how far east or west you are, because the sky moves east to west.
Right.
So North Star is fixed above the North Pole.
Right.
More or less. It'll shift in like 2,000 years or something.
Yeah.
But other than that, it's not going to move, and I can tell how close or far away I am from it. As I go east to west, then the sky rotates. Well, the sun and other stars are going to move, which is like we see that with time zones. If I'm here in Tennessee, it's 7:41. But, I mean, I was in Colorado like 3 weeks ago. When I flew to Colorado, right now, it's 6:41.
Right. The sun's a little bit higher in the sky.
Yeah.
Because it's closer to being
Yeah.
over their heads. I always think of it as like, if it's noon right here, over there it's going to be before noon, and the sun's not going to be quite at the top of the sky. It's going to be like on its way there.
Yeah.
Because it's all the way back over here still.
Yeah, so it's closer to them over there. And we see this all the time because we can travel so quickly now. We deal with time zones and things all the time. So it's really easy just using the planets in the sky to determine north and south. It's really hard to determine east to west. So for years, well, for all of history pretty much, they had difficulty sailing across large bodies of water. So actually the Greeks would sail around the coast. So if they wanted to get down to Italy, there were places where they might could cut across, but a lot of the times they would have to sail around the coast, even though it's not super far, because they couldn't risk getting lost.
Yeah.
So when trade started happening with the Americas, they really ran into this problem of how do we get, because, I mean, one of the biggest things in Americas was tobacco, which is grown in the Carolinas. So if they wanted to come get the tobacco, say somebody in England wants the tobacco, they're at a different latitude than the Carolinas.
Which means the Carolinas are farther south.
South, yeah. So we would think today, why they just sail in a diagonal line across the ocean and boom, they're in the Carolinas.
Yeah.
They couldn't do that.
Right.
Because they can't tell. It's much slower travel. If they're off by a degree north or south, they could end up hundreds of miles off course if they're not paying attention.
Right.
The safest thing for them to do was to sail in a straight line across, hit some point at the same latitude north or south as them, and then they would sail down the coast until they got to the Carolina port.
Right.
Then they would sail back up the coast again and then back across to England.
So they'd sail across to like New York or something.
Yeah, something like that.
And then they would just go straight down.
Yeah. Which was really bad for them because it wastes time. But then also, because there were these latitudes people would sail across on regularly,
right?
Pirates would camp out on these latitudes.
Yeah.
And so that's why pirates, and we've got all these stories about pirates robbing people. It was super easy.
Yeah.
Because they knew, hey, we just wait here a few days. Somebody's going to have to come across this way.
Yeah.
And the merchants knew it, and it was dangerous, but they had no other choice. They just had to risk it.
Uh-huh.
So eventually, a prize was put out in, I know at least England, saying whoever can solve this issue of determining, we can determine latitude, we need somebody to help us determine longitude.
Mm-hmm.
Whoever can help us find a reliable way to determine longitude, we'll give them, I don't remember how much money it was. And so all these people were trying to come up with astronomical ways and all these other various ways of keeping track of where they were. And there was one man, his name was John Harrison. He said, I'm going to do it, but I'm going to do it with a clock. Huh. So the hard part, and this is where we get into one of my favorite things to talk about is clocks. I made my senior project in college out of this. So the hard thing with the clock is most of them ran off of a pendulum which swings back and forth. Obviously, if you put that on a boat that's rocking back and forth, it's going to throw the whole thing off kilter, and it's not going to work.
Right.
And that's why they haven't been able to do it before. So his proposition was, I'm going to make the most reliable clock that I can. The other thing is temperature causes metal to expand or contract, and different metals expand or contract in different temperatures at different rates.
Right.
So he eventually managed. There's a book on it. It's just called Longitude. If you want to read about it, it's fascinating. I love talking about this. But the long and short of it is, after 5 tries, with some near successes, some failures, he eventually built. It looked like a large pocket watch, and he built it to where it had an oscillating motion inside that was not thrown off by the rocking of the sea, and the metals in it, he built them of different alloys that parts of them expanded as other ones contracted, and they kind of bounced each other out.
Whoa.
So it was crazy, and he actually they disputed if he won it or not, so if he ever got the money, it was super late in his life. I'd have to go back and look.
Weird.
But anyway, now that they had this watch, their problem was solved. And so this is actually still the principle that modern GPSs work off of today. They would set the watch to some time local, and then they would just sail off into the ocean. It's really easy, if you know what you're doing, to tell your local time from the sun. What they could then do was look at the time it was back home, see how far off they were, and then based off of the time difference, they could allot how far east or west they were. So now they could sail diagonal from England down to the Carolinas.
Wow.
So they could sail anywhere they wanted as long as they had this watch with them that was set to the local time.
Right.
And because it was popularized in England, they started basing it off the time in the city of Greenwich in England. And that kind of became the standard. And so now what's known as the prime meridian, which is still where we would set all of our date and time things from, like GPSs and whatever, that calibrated from Greenwich Mean Time in England.
Wow.
So even today, GPS works that way. It's a satellite now.
Yeah.
But it's still pinging. There's all these satellites pinging times back and forth to each other, how far apart they are, then how far apart each one is from you and from where you want to go.
Wow.
And so it still works off of the same basic principle, but now it's in space, and we don't have to do it manually anymore.
That's totally crazy.
It's crazy how it's just like this ancient understanding of the stars over the century, people building and building and building and building, gets to just, I mean, it still affects the way we live today. That's how we are able to do so many of the things we do. It's just great. It's crazy to me that you have these people who want to say that the ancients were just not knowledgeable, and we benefit from so much of their knowledge that we just scoff at today. Yeah. It's crazy.
Like, it's silly to scoff at them, which is like a chronological snobbery. Is kind of what it is. I was
trying to think of the term of it. Yeah.
Yeah. Because we stand on the shoulders of giants. Or we also, I think he kind of meant that. Newton meant that a little bit differently. But we stand on other people's shoulders at the very least, even if they're not giants. And we couldn't be where we are today if it wasn't for other people doing what they did, even if they were incorrect.
Yeah.
So
that's part of why, to me, I love astronomy just because, I like looking at the stars, but there's something about just our relationship to the natural world that I think we lose. And a lot of early science was built off of this understanding of us related to the heavens, and we don't study that anymore. And I feel like it's a great loss. I think we need to study it more.
Yeah, I agree. Well, that brings us to the end of our time today. We'll have a blog post up on the blog summarizing this like normal, or we should, assuming Ashton does a job.
If I do my job right. We've gotten a couple questions back recently, so
yes,
that's been great. Thanks Thanks for that. It makes us think harder about how to answer them.
Yes.
I hope the answers we've given are helpful and informative.
Right.
If they're not, let us know that too, and we'll try to get you better ones.
Yes.
But you can find us at The Great Cave Escape at .blogspot.com.
The Great Cave Escape is our email.
Oh, you're right. What is the URL?
I think it's just Cave Escape. It's either The Cave Escape or caveescape.blogspot.com.
If you just Google the Cave Escape blog, it'll pop up at the top. I've
because
checked
we're
it
the only
recently.
one.
Yeah.
Our email is greatcaveescape@gmail.com.
Yes. Which should also be on the blog if you, for some reason,
Right.
can't send one to us. It's on the blog.
We also definitely said it correctly in the last episode.
Yes.
So you could go back there.
Yes, go listen to the whole last episode. And we also do have a Facebook and Instagram. You can message us through there as well. But as always, thank y'all for listening, and until next time, take care.